Today's topic is Haar transform. In the last classes, we have seen Hadamard transform and Wash transform. In Hadamard transform and Wash transform, we have the values 1 and minus 1. And in Haar transform, we have the values 1, minus 1 or 0 multiplied by the power of root 2. So the Haar matrix is like this. It is 8 to 4 order 2 is equal to 1 by root 2 into 1 1 1 minus 1. And for order 4 it is 1 by root 2 1 1 1 minus 1 1 1 1 minus 1 1 1 1 minus 1 minus 1 minus 1 minus 1 minus 1. It is the Haar matrix. Now we are going to see how to generate a Haar basis. This is the algorithm for the Haar basis. It has 6 steps. The first step is determine the order of n of the Haar basis. So this order is usually get from the question itself. So first step is to determine the order n. And the second step is determine small n where that n is equal to log to the base 2n. So we get order from the question. So we can easily determine the small n that is equal to log to the base 2n. And the third step is determine p and q. P value varies between 0 less than or equal to p less than n minus 1. Here lower side have less than or equal to, upper side have only less than, no equal to sign is there. So p varies between 0 less than or equal to p less than n minus 1. If p equal to 0, when we find the value from this equation, if p equal to 0, then q equal to 0 or q equal to 1. If p not equal to 0, two conditions can occur from this equation, p equal to 0 or p not equal to 0. If p equal to 0, then q equal to 0 or q equal to 1. If p not equal to 0, the equation to find q is 1 less than or equal to q less than or equal to 2 raised to p. Here we have less than or equal to in upper and lower side. Here in p we have no equal to sign in the upper side. You have to remember this. Next, fourth step is determine k. K is equal to 2 raised to p plus q minus 1. We get p and q values from step 3. Use that p and q value to find the value of k. K equal to 2 raised to p plus q minus 1. And next step is to find z. Z equal to 0 by n. N is the order. 1 by n up to n minus 1 by n. Z value is this. And we have next step 6. We get k from step 4 by substituting the value. So the value of k can be 0 or not equal to 0. If k equal to 0, then h of z, that is Haar transform, is equal to 1 by root n. N is the order. If k not equal to 0, then we have hk of z. K value can be 1, 2, 3, depends on the value of k. K of z is equal to 1 by root n of plus 2 raised to p by 2 and minus 2 raised to p by 2. And it has some certain conditions. For plus 2 raised to p by 2, the condition is q minus 1 by 2 raised to p less than or equal to z less than q minus half by 2 raised to p. Here there is no equal to sign, less than or equal to only less than. And here this value is taken to here. So minus 2 raised to p by 2 equal to q minus half divided by 2 raised to p less than or equal to z less than q by 2 raised to p. In the upper side there is no equal sign, only less than sign, and in the lower side we have less than or equal signs and 0 otherwise. So its flowchart is represented like this. First determine the order of n. Next determine small n where its value is log to the base 2n. Third step is determine p and q. And the fourth step is determine k where the value of k is 2 raised to p plus q plus 1. Next step is determine z. And using all these values n, p, q, k and z, compute the Haar function hk of z. So these are the steps you have to follow to find the Haar basis of a function. Now we are going to see a problem. Generate the Haar basis for n equal to 2. So question is generate the Haar basis for n equal to 2. So we are going to find the Haar basis for n equal to 2. So first step is determine n. So from the question we get n equal to 2. And the second step is determined small n and its value is log to the base 2n. And we know n equal to 2. So substitute log to the base 2. Log to the base 2 is 1. So what we get? We get n equal to 1. And next step is determine P and Q. We have to determine P and Q. For that first we are going to find P. P value is 0 less than or equal to P less than n minus 1. Here n equal to 1. N minus 1 equal to 1. P has only value 0 value. So what we get? P equal to 0. When P equal to 0, we have Q equal to 0 or Q equal to 1. If P equal to 0, then we have Q equal to 0 or Q equal to 1. And next is step 4. In step 4, we have to determine K. In order to determine K, we require the equation P raised to Q, 2 raised to P plus Q minus 1. P and Q values are required. So P value required, Q value required, and K required. We are going to find when P equal to 0, Q equal to 0 or Q equal to 1. So P value is 0 in both cases. Now we are going to find K. So first substitute first row. 2 raised to P, 2 raised to 0 plus Q minus 1. 2 raised to 0 is 1 plus 0 minus 1 is equal to 0. So first row K equal to 0. When we substitute the second row, 2 raised to 0 plus Q minus 1. 1 cancel, 2 raised to 0 equal to 1. So K equal to 1. And next is step 5. What is step 5? Determine Z. Z is equal to 0 by n up to n minus 1 by n. Here what is n? This capital N is 2 here. Order equal to 2. So 0 by n, first one is 0 by 2 and next is n equal to 2 minus 1, 1 by 2. We have two values for this, 0 and 1 by 2. Z value varies between 0 and 1 by 2. And the next step is h of z, to determine h of z. If k equal to 0, then h of z equal to 1 by root n. We have k equal to 0 and k equal to 1. So for first k equal to 0, then h of z equal to 1 by root n. Here n equal to 2, so 1 by root 2. And for k equal to 1, we have p equal to 0 and q equal to 1. For k equal to 1, we have p equal to 0 and q equal to 1. So for k equal to 1, we are going to find hk of z is equal to 1 by root 2 plus 2 raised to p by 2, general equation. Q minus 1 by 2 raised to p less than or equal to z less than q minus half by 2 raised to p. Same thing here. Q minus half divided by 2 raised to p less than or equal to z less than q by 2 raised to p, 0 otherwise. So we are going to find the conditions for k equal to 1. For k equal to 1, we have p equal to 0 and q equal to 1. And we are going to find the condition. Substitute q equal to 1 and p equal to 0 here. When p equal to 1, substitute here 1 minus 1, 0. Divided by 2 raised to 0 is 1. So it becomes 0. Less than or equal to z less than q equal to 1. 1 minus half divided by 2 raised to 0 is 1. 1 minus half by 1 equal to half. So first row becomes 0 less than or equal to z less than half. And the second row becomes, second condition becomes same. So it is half less than or equal to z less than 1 by 1. So it is 1. So we get two conditions. First condition is 0 less than or equal to z less than half. And second condition is half less than or equal to z less than 1. Third condition is otherwise. And we have z equal to two values. Z equal to, from step 5 we get z equal to 0 and half. When z equal to 0, which boundary condition follows? It follows the first boundary condition, z equal to 0, right? Z equal to 0 here, first condition. So first condition, z equal to 0, this is the first condition. At that time, what is h of z? 1 by root 2 into 2 raised to 0, 1. So it is 1 by root 2 itself. Is it clear? We have this general equation. In that general equation, these are three conditions. We substitute the value of P and Q in these three conditions. In these two conditions, this is otherwise. In these two conditions, so we get two conditions like this. So 0 less than or equal to Z less than half, half less than or equal to Z less than 1, and otherwise. And we already find Z values. From step 5, we get Z equal to 0 and 1 by 2. First, we are going to find Z equal to 0. For Z equal to 0, you have to find in which boundary condition this Z equal to 0 belongs. Here, Z 0 less than or equal to Z. So, it belongs to first condition. First condition means this one. For that, we have the value plus 2 raised to P by 2. 1 by root 2 into plus 2 raised to P by 2. P here equal to 0. When substitute 2 raised to 0, it becomes 1. So, H of Z is equal to 1 by 2. For Z equal to 0, the boundary condition 1 is being satisfied. So, H of Z is equal to 1 by root 2, 2 raised to P or 0 by 2 equal to 1 by root 2. And next we have Z value equal to 1 by 2. Z value 1 by 2. For Z equal to 1 by 2, the boundary condition 2 is satisfied. So, Z here it is only less than half. But here less than or equal to half. Here Z less than or equal to half is there. So, second boundary condition is satisfied. For second boundary condition, it is minus 2 raised to P by 2. So, when Z is equal to half, the boundary condition 2 is being satisfied. H of Z equal to 1 by root 2 minus 2 raised to 0 by 2 equal to minus 1 by root 2. So, the half basis for n is equal to 2 equal to k equal to 0 and 1 and n equal to 0 and 1 n of Z n equal to. And n is found from this n, and when k equal to 0 and n equal to 0, it is 1 by root 2. When k equal to 0, it is again 1 by root 2. We saw it in here. When k equal to 0, h of z is 1 by root 2. K equal to 0, it is 1 by root 2. When k equal to 1, what happens? And n equal to 0, we have 1 by root 2. And when n equal to 1, it is minus 1 by root 2. Where we get that n here. When n equal to 1, it becomes 0, and so from here we have this. So, it is minus 1 by root 2. This is the hard basis for n equal to 2. You have to done it for n equal to 4. Practice it. It is as homework for n equal to 4. Thank you.